Welcome to Future Forward. Today, we're acting as geological detectives, diving into a 4.4 billion-year-old mystery. What did the Earth's first continents look like?
Right.
For a long time, this was a complete blank, a missing chapter in our planet's story.
It's a fantastic analogy, Alex. This period, the Hadean eon, was named after Hades for a reason. It was a hellish landscape, likely molten, bombarded by asteroids, with almost no rocks surviving to the present day. The oldest intact rocks we have, the Acasta gneiss in Canada, are only about 4 billion years old.
Wow.
That leaves a 400 million year gap in the geological record.
A 400 million year gap. That's longer than complex animals have even existed on Earth. So how do you possibly fill that in? The answer from a team at Zhejiang University is both incredibly small and incredibly high-tech.
Yeah.
It starts with a nearly indestructible crystal called a zircon.
Zircons are a geologist's best friend. Think of them as the black boxes of a geological event. When they crystallize out of magma, they trap trace elements, these tiny chemical clues about their environment.
Okay.
And they are tough. I mean, they can survive being eroded out of their original rock, baked, crushed, and recycled for billions of years. We find these ancient zircons, some over 4.3 billion years old, in places like the Jack Hills in Australia.
So we have these tiny time capsules, but the original package, the rock they came in, is long gone. It's like finding a single perfectly preserved brick and trying to reconstruct the entire building it came from.
Right.
How did the researchers make that leap?
This is where the 21st century meets deep time. The team led by Professors Jia Liu and Kunkei Xia built a massive database, over 14,000 zircons and their known host rocks.
Wow.
They then fed this to a machine learning algorithm. In essence, they taught an AI to be a master geologist, to look at the chemical signature of any given zircon and predict, with high accuracy, the chemical makeup of the rock it grew in.
So the AI becomes a kind of translator then, decoding the language of the zircon.
Exactly.
And they pointed this powerful translator at the ancient Hadean zircons.
Exactly. They virtually passed these 4.4 billion-year-old crystals through their model. The AI then generated the chemical profile of their missing host rocks. It's a stunning achievement. It's as if they resurrected Earth's first crust inside a computer. Allowing us to analyze it just like a real sample. We've effectively pushed the known rock record back by 400 million years.
Okay, so the AI has done its work. The lost rocks are virtually reborn. What did they tell us? I mean, what was this primordial crust like?
This is the headline finding. The chemistry suggests the Hadean crust was likely formed through a process called convergent tectonics.
Okay.
This is more like what happens when two continents slowly collide today, with the crust thickening and piling up. It's different from deep oceanic subduction, where an oceanic plate dives deep into the mantle, a process many thought was necessary for early continent formation.
So this implies a form of plate tectonics, or at least plates pushing against each other, was happening far earlier than we imagined.
Right. That must rewrite some textbooks. It certainly offers a powerful new model. It suggests Earth's geological engine might have started up in a different way than we thought.
Yeah.
But what's truly exciting is the method itself. This fusion of AI and geochemistry gives us a new blueprint for tackling Earth's most elusive mysteries. It's a breakthrough not just in what we know, but in how we know it.
It's a profound thought that the key to understanding our planet's fiery birth was locked away in crystals the size of sand grains.
Yeah.
Just waiting for a tool smart enough to decode them. It completely changes our perspective on what's lost to time and what can be recovered. Now, here's a question we'd like you to think about. If artificial intelligence can help us resurrect a 4.4 billion-year-old world from microscopic crystals, what other lost chapters of history, whether in geology, archaeology, or even biology, are just waiting to be decoded?